lecture of the series of the topic that I have been covering, that is soil erosion. In the previous two lectures, I have covered important topics like what is soil profile, what is soil erosion, how erosion happens, and what are the drivers of erosion. Then after that, I have taken water erosion, the cause of erosion by water, types of water erosion, right, and the mechanism of water erosion. Today I will take the new topic that is called erosion caused by the wind, right? How a wind speed can be a potent tool to cause erosion in soil, right? So basically there are some similarities between wind erosion and water erosion on the first hand, right? If we see by mechanism, you will find a lot of similarities between wind erosion and water erosion, because both the process are having on-site and off-site consequences. That means they cause a kind of erosion at point A, and from where they will take the soil with the force of wind or with the force of water to the point B, right? So point A is your on-site consequences and point B is your off-site consequences, where the soil has been taken away. Now there is a difference, important difference between wind erosion and water erosion, that mostly in wind erosion, the wind that moves on the top of the soil, it takes mostly silt-sized particles, right? Silt-sized particles mostly are being taken by wind, right? Wind erosion is also called aeolian erosion, right? So when wind speed is moving at a very high speed, around say minimum 8 kilometers per second wind velocity, if it is flowing on the surface of a soil over 2 meter, right, it can cause erosion. This much of a speed of wind can cause erosion, right? So as we use the term rainfall erosivity and runoff erosivity in case of water erosion, there is a similar term here called wind erosivity, right? Wind erosivity is the ability of the wind to cause erosion, right? Ability of the wind to cause erosion. So wind, if it is moving at a very high speed on the soil surface, it can take the soil away with it and it can deposit somewhere else. And mostly in this case, in case of wind erosion, silt-sized particles are taken away from the soil. Now the top soil which is being taken away by the wind, it goes from side A and accumulates at side B, right? Where it accumulates, it is called the louse formation. Louse means loose, right? Loose silt-sized particles from soil are taken from point A to the other point called point B, right? So this louse particles, they slowly are being taken away by wind and they accumulate at some other place, right? Louse formation, L-O-E-S-S, louse formation is the characteristic feature of wind erosion, right? Louse formation. Louse means loose silt-sized particle movements with the wind, right? So what basically is the mechanism of wind erosion? The mechanism is same as I have discussed with the water erosion. There are three steps into it. One is called detachment, then transport, and then third is deposition, right? Detachment, transport and deposition, this is the mechanism of the process of wind erosion. Same like water erosion. In water erosion also these three steps are being taken, but important here to note is that silt-sized particles are mostly carried by the wind. When wind flows at a high speed, it detaches the soil particle, right? It detaches the soil particle. There is no surface sealing like in the water erosion I have discussed, right? There is no surface sealing. Only the detachment of soil particle will happen. Then it will be transported, process B, and process C. It will be accumulated at a point B somewhere else, right? So there are formation of big structures, loess formation, silt-sized particle formation, right? It occurs. Normally we see and we call them as sand dunes, right? Sand dunes. Sand dunes. Right? Sand dunes. Sand dunes. Right? Sand dunes are the prime example of a place where wind erosion is happening. If you have seen sand dunes, you must be knowing it. If you don't know sand dunes, please go and search about it. What sand dunes are basically and how they are formed. Right. So, but when I say that the mechanism is same, like detachment, transport, and deposition of silt-sized particles, normally silt-sized particles. In case of wind erosion, right, these particles are carried away. But the important thing to note here is that when say these kind of forces which are over the top of soil, right, it is moving. So there are some forces which resist this force of wind. Wind erosivity is being halted or being counteracted by some forces, right? Those forces are basically the natural ability of soil, the soil properties, right? Aggregation of soil, then flat residues present in the soil, roughness of soil, texture and aggregation of soil, crusting of soil, right? Soil wetness and vegetation. These are the forces that resist the force of say soil. See, this is suppose this is the force of wind. It is coming in this direction, right? In this direction it is coming, right? But these forces, the soil wetness, say flat residues, crust on the layer of soil, these are the forces which fight with the wind forces to resist erosion, right? So if a soil is having better water holding capacity, it has holding a better amount of say water, right? Its aggregation is well, right? It is the particles, sand, silt and clay are placed in proper manner in the soil. They are well arranged. If the texture of the soil is having more amount of heavy particles, right, and if there is a crust layer on the surface, these things create a kind of anti-force to the wind force that is coming and taking the soil away, right? So these forces are kind of a drag force, right? It drags the wind down, right? When a wind moves on the soil surface, suppose this is soil surface and wind is moving from this direction. When the wind goes a little bit down and moves the soil surface, if soil has say more drag force, right? More drag force means soils are having say better roughness, right? If soils are more rough, they have different size particles, right? Gravel content, rock content, right? More is the bulkiness of the soil, means roughness of the soil. More will be the drag force. More will be the roughness of soil. See here, roughness of soil. Roughness of soil, right? It is directly proportional to drag forces. Right? Drag forces are the forces which works against the wind, right? When wind is moving a bit down to the surface to try to take the particles away. The space between the air with wind is moving, right, and between the soil surface, the in between place where there will be drag force, and this drag force will be better if the roughness of soil will be more, right? So roughness of soil is created by these properties: soil wetness, vegetation on the soil. More the plants are there on the soil, more it will resist the wind, right? More it will divert the wind. Then flat residues, like when we take when after harvesting some part of the plant or waste plant material which is not utilized by us, right? When they are kept there on the soil, they are called flat residues. Then roughness of soil, texture and aggregation, and crust layer on soil. These things work as a drag force, right? They work against the wind. They work against the wind erosivity of the force that has been created by wind to take the soil away, right? So this is basically from this direction the wind energy is coming, and this is soil surface, and these are the forces which resist the say wind energy and helps fight the soil erosion, right? So apart from it, one more difference between water erosion and wind erosion is that in wind erosion, the particles that move with the wind energy, right, they are moved in three different ways, right? The smallest particles that move, they are called suspension, right? The medium-sized particle which move, they are called saltation particles, and the biggest size particles that move, they are called surface creep, right? So these particles with wind energy, they move with the wind, and the heaviest particles, they settle down first, like surface creep, these kind of particles, right? They are 0.5 to 2 millimeter in size, the particle size. Saltation particles, they are 0.1 to 0.5 millimeter, medium sized particles. They go on when with the force of wind, they go upside on the they go upside the surface, and then they came down like this, then jump there, then jump there, then jump there like this. But the surface field, they move along the surface, right? And the most lightest particle, called suspension particles, which are less than 0.1 millimeter, they create atmospheric dust, right? Suspension particles, they create atmospheric dust and they move on the top, right? And these saltation particles and surface particles, they also, by rebounding with themselves, they collide with themselves also, and slowly they degrade, and this surface field may become saltation particles, and these saltation particles, after colliding with each other and with rebounding, they can become suspension particles also, right? So this is the movement of movement of particles in wind erosion is different from water erosion. So there is suspension, saltation, and surface field particles which move like this. This atmospheric dust in suspension form, this will move, right? Saltating, from the side the wind is coming, right? Suspension will move like this. Then saltation particles, they will bounce and jump, right? They will move like this. Saltation particles and surface field, they move along the surface because they are heavier inside, right? So this is how a process of say wind erosion happens at a particular place. Now I told you that sand dunes are the biggest example of sand dunes, right? Sand dunes are the biggest example of wind erosion, in which slowly wind takes away the soil from a point A and accumulates somewhere else, right? Suppose from this way wind is working, right? So suppose there is sea here, right? Sea, right? So if particles are here, sand particles, side particles which are there, so slowly they will move and accumulate here, right? first sand dune, then by the time the wind keeps on moving, sand dunes keep on forming, more bigger, right? Then more bigger, right? And then more bigger, right? This is how sand dunes are found. The best example of sand dune is this one, Los Plateau of China. Lost Plateau of China. It is 335 meter long sand dune. Right. Biggest sand dune example is Lost Plateau of China. This is in a sandy region, right? So I was saying that if say wind erosion is happening from this side, first silt size particle structure will be here, second will be here, it will be more bigger, third will be here, and fourth will be here. Now the silt size particles, as I told you, clay and silt size particles are say very fertile kind of particles, right? Silt is the ideal mix of say clay and sand particles, right? It is in between the range, right? Clay is the smallest particle and sand is the bigger particle. So silt is the in between range. So these are very fertile particles, right? If sand dune is happening like this, right? So the first sand dune, there will be less vegetation here on the top because say silt particles are getting accumulated here. Then by the force of wind it goes this side and more particles will be accumulated here. Then more vegetation will become here because silt size particles are accumulating. By this point, even more silt particles will be here. Right? By slowly moving of the silt size particle, so more vegetation will be here, right? On the top surface here, right? But finally, when it comes to the final sand dune, which is this one, this will be most fertile one, this one, because all the silt particles slowly they will accumulate here, right? This is how a particular sand dune is formed, especially this kind of process of less fertile sand dune then more fertile sand dune. This process takes place near a sea. If sand dune is getting formed near a sea, silt size particles are being moved away, right? These kind of structures can be seen getting made in these particular locations, right? So Lost Plateau of China is the most fertile kind of silt size particles, most fertile silt size particles, silt sized particles, right? They are being moved, right? They are the most fertile kind of plateau known, right? There are some examples of sand dune formation in other countries also, like semi-arid countries and arid countries. They are known to have sand dune formation. Like in Saudi Arabia, there is a sand dune which is 200 meter long, 200 meter in height, right? So and many other countries are there in which sand dune formation examples are there. You can Google search it, right? So this wind erosion that is happening at a particular place, normally wind erosion happens in those places which are arid in region, right? Dry land region, where rain doesn't happen too much, right? So if I need to write the sequence of erosion happening in area, arid region will be the most prone region to wind erosion, followed by semi-arid region, followed by subhumid region, and after that humid region, right? Because in arid regions the soil surface will be more dry, right? When the wind will move, the soil particles up there will not be holding by the soil because surface is loose, right? And the drag force between the suppose this drag force between the suppose this is wind moving from here, right? Wind energy. This is your drag force, right? Drag forces, right? And this is your soil surface, right? So in arid or semi-arid regions, the soil surface are loose because of less amount of rain. So when wind energy will move, it will be easier for the wind to take away the soil particles in this direction because the drag force will be less, right? Soil will be less aggregated. In arid region, if there is a desert, right? Sands are there, it can easily be moved, right? No plantation, no vegetation, right? So mainly causes of soil erosion, if I have to say, cause of wind erosion. If I have to say, one could be high temperature. Those countries which are having higher temperature, right, arid regions, there the chances of wind erosion is more than high wind velocity, right? If temperature is high and at higher rate wind velocity is there are ample amount of chances of wind erosion, right? Then less precipitation. Right? Less precipitation. If these three combinations are there, high wind velocity, high temperature, less precipitation, and less vegetative cover, right? If these things, these 3-4 combinations work together, there is bound to happen this kind of wind erosion, right? So this is basically what the causes of soil erosion are, right? Then I use the term wind erosivity, right? Wind erosivity is the ability of wind to cause the erosion, right? So what do you say? To measure these wind erosion processes, there are certain models that have been developed. Mostly wind velocity is being measured by certain instruments called anemometer. Anemometer tells you about wind's movement, direction of wind, friction between the layers, right? Velocity of wind. These things are measured by anemometer, and wind erosion depends upon climatic conditions on a particular land, temperature, precipitation, right? pH of the soil properties, right? Like soil aggregating properties, the bulk density of soil, right? Texture of the soil, right? More the amount of silt size particles are there, more they will be taken away, right? Then apart from that, say soil surface properties like topography of the land. It is tilted land. At what degrees it is tilted, right? More tilted is the land, more it is easier for the wind to take the soil from this position, from position A to position B, right? So these are the various things that are being studied: wind velocity, precipitation rate, wind friction, right? And temperature, climatic conditions. These things are learned to understand the wind erosion better. Then measurement of wind erosion can also be done, right? Measurement of wind erosion. Measurement of wind erosion. right? Measurement of wind erosion can be done by three approaches. One of them is say gradient nuclide fallout method. Second is wind tunnel method. And third is say point methods. Right. So there are basically three ways by which wind erosion can be measured. The simplest of them is this one called wind tunnel method. In these kind of methods, different chambers or pipes or tunnels are being made, right? And these specially designed tunnels are being kept at the position where at in situ position where the wind erosion is happening. They are being kept there. There is a fan into it, right? If I have to draw the structure like this, this is suppose tunnel, right? There are fans nearby this area. Wind comes from this area, right? And there are laser, measuring ways in between here, right? Different kind of wind atmosphere is created by the help of the different size fans. Particles go inside here and they are being accumulated somewhere here, right? Right. So I will discuss these three methods in detail in the next lecture, right? So I hope this lecture is helpful for you. Thank you. So we have been discussing wind erosion and its measurement. As I told you, there are three basic ways by which wind erosion, approximate wind erosion can be done. One of them is point measurement, one of them is nuclide fallout method, and one is simple method called wind tunnel method. As discussed previously, the wind tunnel method is the most basic and easy method of measuring the wind erosion at a particular place or in lab conditions also, right? There are specially designed wind tunnel structures. They have a tunnel-like structure, right? And fans are kept, different speed fans are kept on the surface of the this wind tunnel machine, right? So different fans generate different kind of speeds, and different size particles can be studied by wind tunnel method. Basically, coarse particles are easily measured by wind tunnel method. It has a source from which the particles enter here, right? Particle enter here. It has a laser scanner and it has adhesive tracks, right? So there are, depending upon which kind of particles, fine particles or coarse particles you want to study, the movement of the fine particles or coarse particles which you want to study, which is moving with the wind, the design is different. Wind tunnel. Like if you want to collect coarse size particles which are moving with the wind, then the track design, wind velocity, particle size, and duration of sampling will be different for different kind of particles, right? So these four parameters are basic for designing a wind tunnel. Design of a wind tunnel, right? For coarse particle or for fine particle. Wind velocity, different size wind velocity are being generated by the help of fan. There are big tunnel-like structures. These fans generate different speeds so that different size particles go inside. They are being scanned by laser and they are through adhesive traps. They are being collected and studied time and time over and over again to know which size particle is moving more with which kind of wind velocity. Right? There is a relation which is established by the wind velocity which we design, right? which we manipulate, and which kind of particles we are collecting here, coarse size particles or fine size particles, right? And there is a relationship is made, and on this particular wind velocity, this particle is being collected, right? So this is one of the basic method, wind tunnel method. Second method is point measurement. By the name it is clear, point measurement. It uses erosion pins, right? Pins like this, these kind of pins. Right? You can see this pin. These kind of pins are planted inside the soil, one by one at equal distances, right? And through slowly, when the wind will move from say this direction to this direction, from suppose this is the soil surface, right? This is the soil surface, and wind is moving in this direction, suppose, right? So particles will move from side A to side B here, right? So the surface will be a little bit, it will lose the soil from this particular, it will lose the soil particles from this particular places, right? And will accumulate here, right? So these kind of pins will give you an idea how much soil is lost by the time, right? There are certain erosion pins which are being kept on the ground inside, right? And there is a depth gauge here which can measure the amount of tilted soil with the time. With the movement of particles, the soil will tilt, right? So the tilt movement of soil is measured by erosion pins, right? Erosion pins. Erosion pins are used, then say paint colors, they are also used, and sometimes say colored trees are the bottom of the trees are painted with the colors on these tilted lands, right? When the soil will move, right? So the soil will move from, suppose from here, and there are certain plants which we have planted here. The bottom of the bottom of the tree will show that some particles, some portion of soil is being moved away. So we color the bottom of the tree as such that we have an idea that certain amount of soil is getting moved. Same way, the trees can be planted here also at side B where the deposition is occurring of these particles, where it will show when the paint colors are there on the bottom, it will show aggregation of soil there also. So paint colors, erosion pins, and trees are used as a point measurement method, and there is a reference point taken with respect to the reference point. These erosion pins work and gives you an idea how much soil is moving from point A to point B over the time. Third and less used method is this one, radionuclide fallout method. This is basically used in those soils where certain kind of radioactive nuclide has fall and spread equally, right? We assume that certain radionuclide presence is there uniformly into the soil, right? If some accident has happened in some areas, right? Some nuclear accidents, if it has happened in a particular land, we assume by the time the radioactive nuclide which has been mistakenly fallen onto the surface of the ground is equally distributed, and with the time, if wind erosion is happening and from point A to point B, the movement of particles is happening with that radionuclide, because it is equally distributed in the soil, this will also move, right? So the activity of these radionuclide can be measured by spectrometric techniques, right? The radioactivity, mostly this method, radionuclide fallout method. In this particular method, this radionuclide called cesium-137 is used. This is the isotope which is used, right? Because this has a longer, say, half-life period of 40 years, right? So we assume that cesium-137 is equally distributed throughout the land. If you take the example of this land, this is uneroded side, this is slanted land. That means some particles will move from here, they are more. This is called eroded side, and this is depositing side, right? Deposition side. So we assume and we check the activity of these presence of this cesium in these land on uneroded side, eroded side, and deposition side, and we compare it, right? It gives you an idea. The activity is calculated by in becquerel per kilogram, the radioactivity, normal radioactivity method, right? It gives you an idea from which particular site cesium activity is less. That means that particular site is losing the radioactive nuclide. If the activity of cesium is less in these points, right? That means these sites are losing the soil, and if the activity is more at particular site, that means this particular site is gaining more of soil particles. But this method is as compared to point measurement in wind erosion, this method is less used, right? It is costly also. So these three basic methods are used to measure the wind erosion. After discussing this, I think one more thing which is required to be understood in wind erosion is how to stop wind erosion, right? So to stop wind erosion, there are certain techniques, right? One of them is wind barrier method, right? Wind barrier method. Stopping wind erosion, right? So mostly one approach which is used here is to stop wind erosion is wind barrier, right? Normally wind barriers are long trees which are planted along a particular land. Suppose there is a land, right, on which wind erosion is happening. So we deliberately design this land to plant same length trees, right, onto the boundaries of the trees, right. So the wind direction can be averted, right. Wind's direction can be diverted, or if the plants, the trees we have planted there on the surface of the land. Suppose this is the surface of the land, right? Imagine this is the surface of the land. So from this direction wind is coming, right? So after studying the wind erosivity, say what is the speed of wind every season, right? How much damage it can cause. After analyzing all these things, we designed a particular approach called wind barrier method, in which we plant trees along the boundaries, right, like this. Suppose here also, like this, we plant trees. So when wind is coming, the speed of the wind can be diverted, right, by the presence of these trees. If the canopy level is more, the tree is more dense, more effectively it can grow, right. But there are certain studies go into designing this kind of trees. The density should not be as much of the tree that it should completely block the wind coming into the field also. Light also needs to come, right. So the porosity also, porosity and density of these trees which you plant on the surface of these lands in which you are growing something, right. The porosity and density of these trees are also calculated, right. Density means the more dry compared to overall trees which you have planted, the dry area of that, right. The dry area of that is called density of the these particular trees, right. So density and porosity means if the canopy of the trees are there, how much is the pore space between leaves and branches, right. If suppose this is a tree, right, so how much is the, suppose this is 1 leaf, 2 leaf, 3 leaf, 4 leaf, 5 leaf, 6 leaf. So how much is the pore space between here, right? These images of these trees are taken, right? Digitalized photos are taken of these trees which you have planted here, and porosity is calculated by photograph sillets, right? Negative photographs of these trees, right? Sillets, right? These kind of trees in negative photographs of these trees, black and white photographs of these trees are taken, and amount of pore sizes, porosity and density is calculated of these trees, right? So that a perfect balance of porosity and density should be there, that air can come in, right? And effectively it can be diverted also, right? So this is the second thing, and apart from that, crop residues also, right? Wind barrier, crop residues, and this one. Crop residues. This also is a effective way of diverting the wind erosion, right? If crop residues after harvesting the crop, whatever material is left on the field, if it is kept there for a longer period of time, this helps in generating more soil roughness. It increases the soil roughness, right? More the soil roughness, more will be the drag force of soil. More the drag force of soil, better it will be able to combat the wind erosion, right? It will enhance the drag forces, right? More the drag forces will be there, better it will help in fighting against the wind erosion. So crop residues means those residues of plants after harvesting, like leaves, stems, unwanted plant parts which are kept on the ground, which makes a mulch layer on the surface of the ground, which makes a kind of crust layer on the surface of soil. They also help in avoiding wind erosion, right? So after this, we need to understand one more thing, that is what are the similarities and dissimilarities between wind and water erosion, right? So water erosion, basically it is caused by two factors. If I compare wind and water erosion is caused by rainfall erosivity and runoff erosivity, right? These two were the factors. Here the major cause is wind erosivity, right? Other thing is it has on-site, off-site consequences. It also has on-site and off-site consequences. That means from point A, soil material is taken and deposited to point B. So at the point A also soil erosion is happening, and because of excess amount of accumulation at site B, that is also getting polluted, right? So both the point A and point B both are getting polluted, right? One is by erosion, one is by accumulation. This is called on-site, off-site consequences, right? So this is common in both of them, right? Then in this surface sealing occurs. Surface is when the rain occurs, surface is sealed by clay-sized particles. In case of wind erosion, water erosion, right? This is wind erosion. But in case of this, no surface sealing occurs. Right. So these are the basic differences which you need to understand. They both have on-site, off-site consequences. The mechanism is same. They both have detachment, transport, and deposition of the molecules to particular places. Then in wind erosion, particles move by suspension, saltation, and surface creep, but there is no movement like this, no movement like this one, right? In case of water erosion. So there are certain similarities between water and wind erosion, and there are certain differences also. More importantly, the basic difference is that the movement of particle that happens in wind erosion, right? The biggest example of wind erosion is sand dunes and dust bowl. If you search on Google, you will find some information about it. Dust bowl, right? Dust bowl is a phenomenon that happened in America in 1930s, where severity of wind erosion was there at a particular area, right? For many years, this problem occurred there, right? So you need to understand, to understand the wind erosion better, you need to go through with this phenomenon also on internet called dust bowl, which is an example of severe wind erosion in America, right? So in this particular lecture, we covered wind erosion, the mechanism of wind erosion, how wind erosion happens, what are the factors responsible for wind erosion, how wind erosion is measured, right? And what are the things we need to understand to create a wind barrier, the plant species which needs to be selected, their porosity, their density, right? And how these trees should be planted in form of wind barrier to avoid the wind direction, right? And there are certain similarities and dissimilarities between wind and water erosion that we have discussed, and measurement of wind erosion we have also discussed. Hope this lecture is helpful for you in your basic studies. Thank you very much.